Welcome dear friends, this is Mathdoctor and let's begin with Rolle.
It's Mathdoctor.
In this particular lecture, we're going to begin with the important topic for proceeding with the Calculus-1. So this is one of the important topic for proceeding our calculus series. So let's look at the what Rolle exactly tell us. So there are some mean value theorems which we will look in upcoming lectures, upcoming videos. It is derived from that public mean theorems. So this is the theorem. Let's take at the example of quadratic function. So let's look at the Rolle theorem. So first of all, and in the next upcoming videos, you will learn about its derivation and to how it derives from the other mean value theorem. So let's begin with the Rolle theorem. So consider a function fx. Let's look at any function ax square plus bx plus c, and let's begin with some quadratic function. So if let's suppose we are concising ourselves from only a to b, we are taking the value of x from starting from a and to the b. So it can be any a1. Let's make these a something different and these are different. So these are the intervals from where we have to apply our Rolle theorem. So let's see what Rolle theorem exactly tell us. So Rolle theorem simply indicates that if any quadratic equation, let's suppose this is the quadratic equation or either in this way, so it can be depends on actually b, this particular, it can be upward or it can be inward. So let's say this is the point C and lies between these intervals. These values of quadratic function, that is from A to B, this is A and this is B and this is C. So if we have to apply Rolle theorem in any particular quadratic function, let's suppose it has some obeys, it has domain up to all real numbers, and we have to just check from these intervals a and b. We have to apply Rolle theorem. So what Rolle theorem exactly tell us? So it simply tells us there are three cases for application of the Rolle theorem. Case one is fx should be continuous function in the interval in a comma b interval, and the case 2 is it should be differentiable. Fx should be differentiable in a comma b, and the case 3, which is simply indicates that fa must be equals to fb. So let's look at this some example. Like if it is not a quadratic equation, if it is in any form, let's say let's make some cubic polynomial. Let's say this is the, so if we have to apply the Rolle theorem in this cubic, first of all we have to know that it should be so what exactly Rolle theorem tell us? If these three conditions are satisfied, then we have to then we can say that there is some point C lie such that at that place slope of function, that is derivative of that function at that point, which lies between a and b, it should be 0. So this can be derived from mean value theorems, which we will discuss in the upcoming lectures. So I hope you learn this thing properly. So it just say that if any function is there so that values of this is, let's suppose this is a, let's suppose this is a and this is b. Here we know that f of a and f of b equals. So this is the case applied on this particular quadratic cubic polynomial, and fx is also differentiable at every point as it is also continuous function. So there is no discontinuity at any position in the interval a and b. And in the interval a and b also, it is also differentiable at all. So these three conditions are satisfied. So we can now say that there is some point lies where slope of that, so that f of dash f dash c, so that c lies between these points. So this is the point where slope becomes 0 of our polynomial. So this is the point C. So from this particular node, that we know that if there are some points, let's suppose these are the points of where we have to determine the in between we have to determine we can apply a Rolle's theorem or not. So this is we can easily just simply check that there should be point in that particular a and b interval, so that slope at that point becomes 0. So this can be happen if we apply these three cases. So this is just Rolle's theorem would exactly tell us. So let's look at some examples. So look at in this particular example, we are going to verify the Rolle's theorem. So let's begin with. So let's begin with drawing the graph of particular function, that is x square. So this is the function. We have to determine, verify the Rolle's theorem in this particular interval. So let's look at. So first of all, there are three conditions. So it is also continuous because it is a polynomial. So if fx is polynomial, it must be continuous and differentiable. It is continuous and differentiable at any point. So first two conditions are satisfied. Okay, then we have to determine third condition, that is f of 4 minus a should be equals to f of 1. If this is the case, if this becomes equal, then we have to then we can verify the Rolle's theorem. So let's look at the third case number 3. Case number 1 and 2 is continuous and differentiable. So it is differentiable in every real number. So it must be differentiable in R. So in that particular interval also. So let's say f of a, third condition, f of a and f of b should be equal. So this is the interval. So f of minus 1 and f of a. So this can be written as like that because fx is x square and f of 1 should be 1 square and this should be equal 1 to 1. So this is how we verify theorem. So these three conditions are satisfied. Then we can say that, of course, we can apply Rolle's theorem in the interval minus f of c equals to 0, such that c lies between minus 1 and 1. So as we see from the graph, it is obvious that f of 0 is f of slope of at this particular point is 0. So it simply indicates that Rolle's theorem must lie between these intervals. So using the graph and using the derivation which we have done. So let's look at another problem. So in this problem, we have given a quadratic polynomial and we have to determine whether Rolle's theorem is applicable in this interval or not. So let's draw first of all this graph. So case 1 and case 2 are applicable because it is polynomial. So it must be continuous for any real number and differentiable at any point. So first two cases are satisfied. So what will happen if we see these cases? So let's see. So first of all, we have to draw the graph of it, that is minus 4x minus 2x plus 8. So it should be x into x minus 4 minus 2 into x minus 4, and it is equal, it becomes x minus 2 into x minus 4. So we can say that simply these are the 2 points where it becomes 0. And 2, so at 2 it becomes 0, and at 4 it also becomes 0. So here it goes. Here this graph goes. It can be like this or this, depending on this particular thing. It is if minus, it is in minus, then it is obviously inverse. So it will depend on this thing. Okay. So if this is the graph, and we have to know that we can easily find that f of 2 will also become equals to that. F of 2 should also become equals to 0 in this particular graph, because it is also 0. F of 4 is also 0. So these are three cases are satisfied. So hence we can say that Rolle's theorem is applicable. So as it is also seen from the graph that this C point lies in the interval such that slope at that point, f dash of that point is equal. Slope of that is equals in the interval 2, 4. That's the idea about this lecture. I hope you enjoy my lecture. So see you in next video, so next theorem. So this is all about the Rolle's theorem we have discussed so far today. So meet with you the other mean value theorems. So in the upcoming videos. Thank you all of you. Keep sharing my content and don't forget to like, subscribe my channel. Keep studying, keep working hard. Thank you.